Hello, so I am back to the part about simplifying, which is our main idea today, okay? Simplifying each expression. I wrote a hint for you here. To simplify a trigonometric expression, start by rewriting in terms of one trigonometric function. I'm trying to condense it, make it shorter, smaller, or in terms of sine and cosine only. So I have many methods or ways I will apply as much as we can from the algebra book and from the pre-calculus book, as I told you, to try to get how to simplify before I move to the next lesson. Okay, from your book, page 658. The first question said simplify tan cosine squared theta. So I'm all alone and I don't know what to do, but one of the options said here, try to rewrite them in terms of one trigonometric function or in terms of sine and cosine. So I have an option to think about sine and cosine because I know tan theta is equal to sine theta over cosine theta. So I'll start, I will not stay stuck there. I'll try, okay, sine theta over cosine theta times, I will just write this as cosine theta times cosine theta, trying to clarify. Cosine squared theta, I just changed it to those. Why? Because I have a feeling that I'm going to cancel one of these with one of those. Clear? So the answer is sine theta, cosine theta. Can I do anything else? I cannot. Never change from sine and cosine to cotan and to tan and to cosec and sec. Simplifying means returning them to sine and cosine, okay, and not the opposite. So this is the answer of question number 5. Question number 6. Again, I have a reciprocal identity and I have quotient identity over here, and they're squared. So cosec squared theta, I can change it to 1 over sine squared theta minus. This was a quotient identity which says cotan theta is equal to cosine over sine. But here it's going to be cosine squared theta over sine squared theta. مظبوط؟ مظبوط. طيب, I have like denominators, so I can write it as 1 minus cosine squared theta all over sine squared theta. It didn't finish yet. Why? Because I have Pythagorean identity that tells me sine squared theta plus cosine squared theta is equal to 1. Who will tell you? Nobody will tell you. By practice, you will learn this. So 1 minus cosine squared theta is equal to sine squared theta. So sine squared theta over sine squared theta, and this is equal to 1. Actually, your answer in the end is 1. By the way, there was an easier way if you went back to this Pythagorean identity and you just moved the cotan over here, right? The question is cosec squared minus cotan squared. If you move the cosec squared minus cotan squared, you would have realized that the answer is 1 in one step. Anyways, we forgot the identity, or I forgot to apply it. I will write the other option over here. Cotan squared minus cosec squared theta is equal to 1. And you're done without changing them to sine or cosine. Okay, question number 7 gave me, I can see here something I can deal with, and here something I can deal with, right? So I'm gonna rewrite it as cosine theta times 1 over sine theta divided by sine theta over cosine theta. This is the tan, right? Okay, let's try to arrange it a little bit. So it's cosine theta over sine theta multiplied by the reciprocal of this, right? So multiplied by cosine theta over sine theta. I'm not going to stop, I can still do more. So cosine squared theta over sine squared theta. Okay, can you know something about this? I know that cosine theta over sine theta is equal to cotan theta. So these will definitely equal to cotan squared theta, and here I am done with my simplification. Clear? I will pretend it's clear because I am here all alone. This is the other question. What do you think? For me, I would see taking a greatest common factor might be very helpful over here. Might be, because I can see a sec and I can see a sec. You can start it with the way that you want. And you reach the right answer, or you simplify as much as possible until you find nothing to do. For me, I would take sec theta as a common factor. And then here I am left with tan squared theta plus 1. And there's an identity for this. Tan squared theta plus 1 is equal to sec squared theta. You will have to memorize them. You have no choice. So I can say that cosec theta is equal and multiplied by cosec squared theta, because this is equal to this. Multiply them, your answer is there. Sec cubed theta. One other student would want to suffer. Let her suffer. She can go and start telling me, okay, this is 1 over cosine theta. I'm going all to cosine and sine. Times sine theta over cosine theta. Plus sec theta, which is 1 over cosine theta. Right? And then she would find herself stuck with these. I'll just focus on here. So it's sine theta over cosine squared theta plus 1 over cosine theta. As we do with numbers, we will do with trigonometric functions. I cannot add them because they're unlike denominators. This is missing 1 cosine theta to become cosine squared theta. So I'm going to multiply by cosine theta over cosine theta to try to make the denominators equal. So it's going to be sine theta plus cosine theta all over cosine squared theta. صح? صح. Where am I going? I'm going to nowhere, actually. Okay. So let's say I'm gonna keep it this way. Sine theta plus cosine theta multiplied by, if I take this upwards, it will be sec squared theta. مظبوط? Or let me split. But if I split, I'll go back to where I was from the beginning. So now if I start, it took this upwards, okay? If I start distributing, I will have a sine theta sec squared theta plus cosine theta sec squared theta. Okay, and then where am I going? Nowhere. Sine is 1 over cosec. See, I'm not reaching anything. Sometimes you will feel stuck, then you will have to think of another way. But I'm sure I can handle this. I'm sure, yeah, I am lost. Oh, I cannot split here, because if I split, I'll go back to the beginning, right? And now when I distributed, I want to reach sec cubed. How will I reach sec cubed? Okay, regarding this part, I'll deal with it, I will deal and show you all the steps, not to make the video longer. I will deal with this part, and I'll show you all the steps how to reach sec cubed with this silly long way. But over here, this was much easier and simpler, of course, okay? Now, I have one co-function identity here, so I'm gonna deal with it, okay? أريح لي بدل ما يكون عندي cosine pi over 2 minus theta, I can change it to sine theta. And the cotan theta, I can change it to cosine theta over sine theta. And this will cancel this, and the answer is cosine theta. I love this chapter very much, very, very much. And I really want you to understand it, not just like applying. I want you to really understand it well. Okay, so I have an option for cotan to change it to cosine over sine. And I have an option for sec to change it to 1 over cosine. And this will cancel this. I will end up with 1 over sine theta. We do not prefer trigonometric functions in the denominator as much as we can, so I'm gonna change this to cosec theta. مع ان هي كانت lovely sign, بس in simplifying we do not prefer this offer. We do not prefer trigonometric function in the denominator, so I'm gonna change it to cosec theta. The next questions: sine theta times 1 plus cotan squared theta. Okay, before I start distributing and giving myself hard time, I would think of 1 plus cotan squared theta. Does it remind you with Pythagorean identities? Yes, it does. Cotan squared theta plus 1 is equal to cosec squared theta. You can make it easy for yourself, you can make it hard for yourself. Cosec squared theta. So sine theta times 1 over sine squared theta. What will happen now? This is, like sine theta times sine theta. One of them will go with these. And I'm left with 1 over sine theta. And so the answer is again cosec theta. One co-function identity again here. Sine pi over 2 minus theta was cosine theta times sec is 1 over cosine theta. This will cancel this and your lovely answer is just 1. Okay, these are the negative identities or the odd and even function identities. Cosine negative theta was equal to what? The same as cosine theta. And sine negative theta was the same as negative sine theta. Okay, what is cosine over sine? It's cotan, but I have a minus here. So minus cotan theta is the right answer. I have plenty of them, and I'm really enjoying it. The next pack are questions 28 to 33, and I'm done with this part. Or actually I will get other questions maybe from the pre-calculus, but not in this video. Okay, so does this remind us of something? Yes, it does remind us of the Pythagorean identity that has cosine and sine in it, right? So 1 minus sine squared theta is equal to cosine squared theta. Cosine squared theta over sine squared theta. What is cosine over sine? It's cotan. So in this case, it will be cotan squared theta. And you're done. How can I check? Yeah, you can check sometimes. If you substitute here numbers and substitute in this one, you should get the same answer. But actually, you don't have a cotan on the calculator for this one. Maybe get the tan and get it reciprocal if you want to check. I have an option for tan and I have an option for cosec. Tan, I can change it to sine theta over cosine theta if you memorize that. Over 1 over sine theta. This cancels this. I'm left with 1 over cosine theta. I'm left with sec theta because we do not like trigonometric functions in the denominator. This is question 30. 1 over sine squared. Okay, I have the same denominator, right? So I can directly subtract 1 minus cosine squared theta over sine squared theta. 1 minus cosine squared theta again reminds me of the Pythagorean identity. 1 minus cosine squared theta is equal to sine squared theta. So sine squared theta over sine squared theta is of course an orange over an orange, and the answer is 1. I can see this is going very nice. I hope you're understanding. Question 31. Okay, I can feel I can use some Pythagorean identity over here, which is this one. The third one, cosec squared minus cotan squared is equal to 1. So the answer is 2 times 1, which is 2. Here I'm done. This look like difference of squares, right? They are actually difference of squares. And if you realize that, you just multiply first with first, last with last, because the middle terms will go anyways. One will be sine theta, one negative sine theta. So 1 times 1 is 1 minus sine squared theta. And what is 1 minus sine squared theta? Cosine squared theta, Pythagorean identity. What about these? How will I start? I will start by taking 2 as a greatest common factor. It's very obvious here that I have a greatest common factor. 1 minus sine squared theta. And what is 1 minus sine squared theta? Cosine squared theta. And this is the answer to cosine squared theta. I'll just stop this video for now. I hope it's going good with you and your understanding, inshallah.